Derek Morris, and he will be speaking on the use of Python scripts to compare and contrast photo images. Mr. Morris.
Good morning. As Dr. Hitchens said, my name is Derek Morris Jr., and I'll be speaking on the use of script to compare and contrast photo images. So in this project, Python script was written to perform an image comparison. This was done with various libraries that are included in the Python language. The program would ask the user for two images and the size for the image. The program would then display the pixel values for the images as well as display the image where if the pixels of the two would match, the image will black out for the section. So I'm going to tell you a few things. A few libraries that we use was Python image library, which provides Python interpreter with images edit capabilities. We also use OpenCV. So OpenCV was started at Intel in 1999 and first came out in 2000. OpenCV now support multiple algorithms related to computer visions and machine language and is expanding day by day. So OpenCV support a wide variety of programming languages such as C++, Python, Java, and is available on different platforms including Windows, Linux, OS X, Android, and iOS. Another library was NumPy. NumPy is a fundamental package for a scientific computer within Python. It contains other things like n-dimensional array objectives, integrated C and C++, Fortran. It's useful for linear algebra and Fourier transfer. Some methods that we did. So for the Python program, the team researched many Python topics such as how to open an image and also how to get the pixel value on both images. This knowledge provides a foundation that was used to build a Python program that would ask the user what two images that the user wanted to compare and display a pixel of the data for the two images, and finally output the picture that shows the difference between both photos. It was discovered that unless two images were the same size, the program could not compare the two images. The program was altered to ask the user what size picture the user wanted. So here's some code for you. So we created a class called Python comparison. Inside the class, we create a function which calls the function of the image. So we use a formula, string minus image, just to get the pixel values from it. And then again, when the program runs again, it'll ask you for the second image for the same thing as well. So in this code, when the code runs, it would ask you, do you want the width, what size width or what size height that you want to put the image, and for the second, we'll ask you, do you want to keep it as the first or you want to change the size of that as well? So our focus was using JPEG and PNG files. So if it was not like a JPEG or PNG file, it would the code would tell you that it was not a PNG or a JPEG file. It would notify you. So when the first image run, it would tell you the status of that image. So it would tell you if it was complete or we had an error for that. And then it'll tell you in a 10-second lap, and then it will run the second image for you as well. So once the pixels were compared, it would ask you to rename the file. So you can rename it however you want. Just know you put an extension to it after. My bad. Hold on, I gotta go back one. No, I lied. Okay, yeah. So yeah, it will ask you to rename the extension, and you can put it whatever you want. You save it as PNG file, whatever you want to save it as, and then it will display the new image that you compared with that image, with the two images you compared. All right. So the Python script that we compare and contrast for the two photos was set by the users. So you can use any image that you wanted You can put it inside the code, and then it'll run for you. So by printing out each individual image, the pixel value is displayed on the screen and organized in descending order by rows and columns. The image of the same width and height are recommended when comparing. As the team advanced in the Python script, two large images were compared, but of different sizes. So here were some of the issues that we ran through. So we had like some infinite loops, RAM limitation, and library dependency. So, however, the overwhelming amount of data being produced within the CPU results in the system crashing on various occasions. When the two images are at different sizes or compared, the image matrix ratio will process in an error. Maybe it depends on the image itself, due to the image size not being compatible. So like I said before, it'll take two images. So we have an image on the left, image on the right. It'll take those two images, compare the pixels of those, and then you'll get the blackout, which you see at the bottom of the comparing pixels. So to process the comparing multiple images, the Python script granted the user options to select between resizing an image and maintaining the current form. By resizing a photo to an equal size, the image are reduced or enlarged by the CPU and are subtracted by the other procedures an image that is contracted. So after testing the code, the team determined that multiple images are different types could be compared based on the pixel. However, images must be resized to the same width and height to oppose the image. By reflecting on the data, Python image libraries and modules were rated to produce higher statistics and image variables over a majority of the program language. The team also concluded that image comparison is not the same across different platforms. So you will have to change the code due to the different, if you use Windows, iOS, or something like that. Each operating system contains their own modules and necessary drive required to execute the program, even when they utilize the same Python library. Because for the program that we use, we have to use Python 3 in order for the code to work. So in the future, the team planned on manipulating the code to compare multiple images at once rather than two images and producing more efficient results. Based on the data produced by the Python program, the script limited the user to operate two images to reduce the amount of system errors and crashing. And in more professional setting, operating a lower and more balanced time complexity will be recommended. However, develop a method that would deliver faster and sharper image comparison and will deal for researchers in the STEM field. Image processing programs are developed to detect anomalies with various and diverse images. Therefore, the deployment of the script is critical towards the certain performance. That's my reference. So now I'm going to actually show you what I actually was doing with the code. So now it asks me for the image. So I could pick the image that I want. So then it asks us for the second image as well. Now it's asking me for what size image do I want. So I can pick any size that I want. So I'm gonna go with probably 400. And then the height, I'm gonna just keep it the same as well. So now it asks me for the second image that I want. Do I want to keep it? Do I want to do it the same as the first? So I'm gonna click yes for the option. So it opens the two images, and now it's running the code. And it's doing the rows and the columns in descending order. And see the pause right there, says status complete, then it goes to the second image. So that's complete. Now it asks me to insert a name for the new image. So I'm just going to see I'm clicking here, cmp.jpg, and it'll run the image, make sure everything's fine. But here is the image that it compared. Right here, you see where all the blackout at. That's a comparison of the pixels for you. Any questions? Yes, sir.
You see the two source images?
The two images that it was comparing, right? Yeah. Yeah. Any other questions? Comments?
How long did it take you to work through this? Was it a semester?
Oh, it was a semester project. It was, yeah, we did it last spring.
And then which kind of class was the class you were working? Was it a computer science class, a geography class?
It's actually a program that I'm in. It's a social program. Every spring we do actually like a team project, everybody. So I was like the mentor for this project actually. So, and yes.
Have you tried doing land cover change analysis with this?
I have not.
Something we look at.
Okay.
You can download Landsat imagery, for example, for free.
Any other questions? Well, and to answer, to comment on that one too as well, we are probably try to do that because we got a remote sensing program, so they probably will try to implement the satellite imageries of pictures as well.
I'd be curious to see the results.
Any other questions? Comments, concerns? All right. Yes.
What other thing did you see coming out of this project?
Hold on, I can't hear you.
What other possibilities did you see extending this project?
And when you said it, like, what else we trying to do with it as well, or?
What else you thought you might be able to do with it?
I
see the comparison of the image.
Right. So, like, I'm gonna basically refer back to her question. So, with the remote sensor program, we do a lot of imagery, and over the years, they trying to figure out, is there a lapse with the cloud covering from like 2010 or 2011? So they trying to see has it changed or anything. So I would say that would be a good way for this code to actually use the pixel comparison to see if there was a change or not. Not a problem. Any more questions? Thank you.